So before we get into the actual code, let's do it visually so we know what we're doing. So we're going to create a function that creates a square based on 2 points. So the bottom left of the point here and the top right here. So you give it 2 spaces or 2 coordinates in space, it just draws a square like that. If this was the other 2 coordinates, it draws a square like that. If there were 2 coordinates right here, it would draw a square like that. So how do we get a checkerboard pattern based off of this logic? Let me just clear all this. Well, we're going to have 2 loops, one to handle the rows and one to handle the columns. The first loop for, we'll just say I is equal to 0. I is less than what? Well, this is the bottom left, top right, bottom left, top right, bottom left, top right, bottom left, top right, bottom left, top right. No, because I would create a square off of the canvas. So we only need the loop to go from 0, 1, 2, 3. So I is less than 4. We could absolutely do I is equal to less than or equal to 3, but this 4 dictates how many squares on the left and the right, or the length and the width. So just nice to code it like this, where I is less than 4, not I is less than or equal to 3. And so same thing for the column space. Square here, point here, excuse me, point here, right here, point here. No, because that would be off the canvas. And so same thing, 0, 1, 2, 3. So within this loop, we're going to have another for loop where j is equal to 0 and j is less than the 4, the number of squares per side, per length, per width. And so all we need to do is, given these for loops, is calculate the bottom left and the top right of each square. Let me just show you the pattern quickly. So how about this? Let's take away those 0s and 1, 2, 3s. Those 0, 1, 2, 3s are just for the for loop. Those are not actually the coordinate spaces. We're going to calculate those in a second. Let's do Control-Shift-J's. Yeah, there we go. So just do square here, square here, square here, and square there. All right, so for this first row, what are the x values? Well, that's 0.0. What are the x values here? Well, we have 0 to 1 on the x-axis. So for a canvas, it goes from 0 to 1 on the x, 0 to 1 on the y. 1 divided by the number of squares per side is equal to 0.25 increments. So each increment, or each square, is 0.25 units by 0.25 units. So the x here is 0.25, the x here is 0.5, the x here is 0.75. And of course, we don't care about this guy right here. And so what are the y values of all these points? Well, they're all 0, right? They're not jumping up to this line, which would be 0.25 on the y, on the y-axis. So this is 0 right here, this is 0 right here, this is 0 right here, and this is 0 right here. Now let's do the top right corners of these squares here. Let's delete that. So what's the coordinate here, the x here? Well, 0.25, 0.5, 0.75, and for this guy, we need the 1.0. And of course, we need this coordinate because this coordinate finishes off this box. This coordinate is not the bottom left to a box here. And so what are the y values? Well, we just jumped up one. So it's 0.25 here, forget the writing, 0.25 and 0.25. So you see this pattern where the x's go from 0. Whatever, 0.0, 0.25, 575, 25, what is this, 5751, and the y values stay constant. So the y values here are 0, 0.25, 0.5, 0.75, and then finally 1 point over here. So I know this looks confusing, but let's go into the actual code and you'll see what we're working with. So let's start by creating that function that draws the squares. So we can just extrapolate it from here. Let's go, it's going to create a vec3 get square. So we're going to need a vec2. We need the current pixel running the shader. So vec2 st. We need the, let's say the start position, the bottom left. So it's going to be a vec2 start. We need the top right. We'll say that's the end. So vec2 end. And then we just need a color that they give in. A vec3 of a color. We can copy this code here. Cut this out. Paste it here. The left bottom will be this, will be the step of the start. This will be the end, which is the right top. And then we're just going to return the color. Return the color times that stuff here, the left bottom x, all the components multiplied out. There we go. And of course we need the canvas. So let's do vec3 canvas, and we'll set the canvas to black. It's equal to vec3 of 0.0. There we go. Just to make sure this thing's working, let's feed a square into it. I'm just gonna say vec3, I don't know, square 1 is equal to get square. Not like that. Get square. It needs the st, so we'll pass the st. It needs the starting point. We'll just say 0.0. It has to be a vec2. So vec2 0.0. We'll do an end of vec2. Let's go 0.25. 0.25 and a color of vec3 1.0. And then finally we'll just mix it in like this. So canvas is equal to mix the canvas with the square 1 using the square 1's interpolation. Do I not have it? Square 1, there should be a comma. There we go. And of course we can change the color like this. All right, so we have a function up and running that gets a square. Let's create those two loops I talked about. We don't really need this. Yeah, we'll keep that. Actually, no. Delete these two. So the first for loop is going to handle the rows. We'll do let I is equal to 0, I is less than, and we want to declare some sort of variable for the number of squares on the width and the length. So we'll just do this. We'll do a const int of, we'll say squares is equal to, we'll do 4. And less than the squares, I plus plus. And it shouldn't be let, that's a JavaScript thing. It should be int I. There we go. Let's do the second loop. So 4 int j is equal to 0. J is less than these squares. J plus plus. Let's call our get square function. So we're just going to say, we really don't need, we just need to do a vec3 of a square is equal to get underscore square. And we have 4 arguments. So the first argument is the st. The second argument is some sort of vec2 with an x and a y. We'll get into that in a second. For now, I'll just do 0.0.0. The third argument is the end. Same thing. I'll just do 0.25. 0.25. And the color vec3, we'll just do this, and then I'll do this. Something like that. And finally, we do the semicolon here. And we have to add it to the canvas here, every loop. So canvas is equal to mix. So mix of the canvas with the square we just created. And finally, interpolating on the square. So we have the this loop running 4 times, or 0 to 3, 4 times. It's just drawing the same square over and over again. How do we get it to alternate or create the checkerboard pattern? Well, we just need to increase the x values here, the columns by 0.25, the increments, and the y's stay constant. So for these 4 guys, the y's constant. For these 4 guys, the y's constant. For these 4 guys, the y's constant. But the x is always changing. So 0.25 here. 0 here, 0.25 here, 0.5 here, 0.75 here. Let me show you that. So we need to know the increments of the canvas we're working with. So we're just going to say int, it's going to be a float actually. Increments is just going to be equal to a float, or 1.0, like this, divided by, we're to cast it, so a float of squares. That should give us for this the 0.25 increments. And so for the starting point, the bottom left point of the x, we want the increment times a float casted by the j. So this j is going to loop through. So 0.25 times 0, 0, which is this guy right here. 0.25 times 1 is 0.25, which is right there. 0.25 times 3 is going to be over here. 0.25 times 2 is going to be right here. And then 0.25 times 3 is going to be right here. And of course, it doesn't do 0.25 times 4, which would be this bottom right corner right here. And so for the y value, we just need a constant per row. And these are the rows here. So we're just going to say increments times a float of the I, like that. And let's just spell it correctly. can also call this interval. We'll just call it increments. So as you can see, we're already establishing this. I don't know if you can see it on your screen, but there's a square here, there's a square here, there might be a square here. So let's do the top right of these squares here. And of course, the top right is just like how we did with the bottom left. The x value increments while the y value stays the same. It's just one coordinate ahead. So the top right here is 0.25, whereas the bottom left was 0. So it's just one interval ahead. So it's going to look like this. This exact same thing. Increments times float of j plus 1. There we go. As you can see, we're making progress there. And the y value, of course, is constant, but again, it's just one above. So for the bottom left, the constant is 0. For the top right, the constant starts at the 0.25 mark. So we can say the exact same thing here. So increments times float of I plus 1. And so why is it not showing up on the whole canvas? This is just how the step function, this particular algorithm works. The bottom left is defined this way. So let's do this. Let's do red. So the bottom left coordinate is defined by an x that goes from here and a y that goes here. An x that goes here and a y that goes here. An x that goes here, y that goes here. The top right is not defined by x, y like that. It's actually defined like this. The x in the opposite direction and the y in the opposite direction. X in the opposite direction, y in the opposite direction. This like this. So in order to get the top right of the logic of the square, we need to go in the opposite direction. So if we go in this direction here, left, up, just to get in the opposite direction where we go, excuse me, that was right, up. To get into left, down, we can just do the 1.0 minus this. So we're just going to flip the direction we're going in. So watch this. So for the top right, 1.0 minus, and then 1.0 minus here. And there we go. We're just filling up the canvas there. Now, how do we get so all the squares are there. How do we get them to alternate their value, their color? So we're just going to do something like this. We create a switch or a flip like that. So we're just going to say Boolean flip. We start off as false. You can start off as true. Doesn't really matter. So we have the flip. When we flip the true or false, it's 0 or 1. So it's black or white. So after we've done a row like this, after we're done adding, we're just going to say something like this. Flip is equal to whatever the opposite of the flip is. So as you can see, we have the alternating colors on the side here. This works for odd numbers. It doesn't work for even numbers. How do we fix this? Well, the flip only works here. So it goes from black, white, black, white here. We need to flip or alternate on the y-axis as well. So we're going to introduce another variable like this. We'll call it the bool, let's say start color is equal to, we'll say false. And since we're just starting with that color, we can do something like this, where you're just equal to the start color. There we go. And so this represents a row we're filling in. Every row, we need to flip the start color. So we'd say start color is equal to whatever the opposite of the start color is, like that. And then the flip can be equal to the flipped start color. Might be a bit confusing, but just think it over. It'll make sense. So there we go. Now it works for odd numbers and even numbers. So it's 3, it's 4, 5. I tried 500 and it crashed the program. The highest I got was like 150. I'll do 120 right here. That's 120. Of course, we can do 1, which is nothing. Or excuse me, it's 1 square. It just starts on the on black, which is false. We can start on true, which is white. We'll go back to black. And then we'll just do, I don't know, 3, 4, 5. Anyways, to the guy who asked the question about how we can make a checkerboard using only the step function, but no, I think he said no branching. And I think it's if conditionals. So this does use loops. It just doesn't use if conditional statements like that. Anyways, to that guy, I hope this answers your question. Leave a like, subscribe if you haven't already subscribed, and I will see you guys in the next one.